probably haven't seen before. So the last one, you should have seen those at least in Algebra 2, but I know some of you haven't taken Algebra 2 for like 2 years, or it was remote learning. So those factoring strategies, they take a lot of practice, but these are 3 more strategies that I least like to show pre-calculus students. One is factoring by grouping. So there's 4 terms. So you may or may not have seen grouping before. If you don't like grouping, you could still use the box method. So I'm going to show you that method second. But the grouping method, you group together the first 2 terms and the last 2 terms as long as it's in standard form. So standard form is highest down to lowest term. And you take the greatest common factor out of the first parenthesis. So the greatest common factor here is just x squared, because I can divide both terms by x squared. So if I divide both of these terms by x squared, see how I have x left and -3 left. So x minus 3 goes in that first parenthesis. There's my greatest common factor, and there's what's left. So I'm going to do the same thing over here. That negative goes with that 16. So I want to force the inside parenthesis to be x minus 3 so they come out the same. So I'm going to take out a -16, and see how when you divide this by -16, you get x, and when you divide by -16 here, you do get -3. 48 divided by -16 is -3. And see how they came out the same? So this is how I know it's factorable. Now I'm going to pull the x minus 3's out because those are inside both of those terms. And now I have x squared left from the first term and -16 left from the second term. So that becomes the second binomial of the factor pairs. So a cubic function, you might be at the end, but you might not be. So I could actually go one step further because I see a difference of squares right here. So the reason we reviewed difference of squares, that should like be a red flag in your brain. So the final factored form would be x minus 3, and then hopefully you know difference of squares, x plus 4, x minus 4. So a cubic could have 3 separate factors. So that's kind of something new that you probably haven't done before. Now, I'm going to do it on a blank sheet of paper for the video's sake, but you don't have to write this down. I just want to show you, if you wanted to do this exact same problem using the box method, when you have 4 terms, you put x cubed minus 3x squared minus 16x plus 48 inside your box that you're used to setting up, and then you just solve your box. So I'd want to put like x squared over here, and then x times x is x cubed. X squared times -3, -3x squared. And then x times -16, -16x, -3 times -16 is 48. See how you get the same set of factors? So if you like the box method better than grouping, I don't care which method you use. I usually use the grouping method, but if you're familiar with the box method already, throw those 4 terms in. So I'd like you to try part B, either doing grouping yourself or the box method yourself, and see if you can factor part B. And then I'm gonna do it together in just a minute, but I'd like you to at least try it yourself first. All right, so I factored out an x squared, got 2x minus 5. Here, the greatest common factor was just 1. So I put a 1 there as a placeholder, greatest common factor, 2x minus 5. They both came out as 2x minus 5. So 2x minus 5 times x squared plus 1 is my final answer. I cannot take x squared plus 1 and factor it. So you can only factor difference of squares. The reason is, if I try to factor x squared plus 1 into like maybe x plus 1 times x plus 1, that's not allowed. Because if I FOIL this out, I get x squared plus 1x plus 1x plus 1. Those are not the same, right? This is x squared plus 2x plus 1. So those are not equivalent factors. This is considered prime. So prime means it can't be factored any further. So we just leave it as a factor of x squared plus 1. So that's the idea of using either the box method or grouping to now factor a cubic function. The reason we need to know if things are factorable is we're going to study rational functions. So kind of next week, but x squared minus 4 over x squared plus 6x plus 8. So that's a rational function. It's a fraction with two different polynomial functions. You need to be pretty fluent in, okay, this factors into x plus 2, x minus 2. This factors into x plus 2 and x plus 4, because 2 times 4 is 8, and 2x and 4x adds up to 6x, to realize they have a factor in common. So if you can't get from unfactored into factored form, it's going to make analyzing a rational function like impossible for you. So I really want you to practice those factoring skills. And like these are a little bit, you know, we're not going to be doing a whole lot of these factoring skills, but it's just kind of nice to know if you have a cubic function, you could take it a step further. And these sum and difference formulas, I'll put these right on a quiz or a test. So you don't have to memorize these cubic factoring formulas. I'll just give them to you on there, and if I forget, I'll write them on the board. And you know that a perfect cube is a number times itself 3 times. So like -2 times -2 times -2 would give you -8, right? Or 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. Those are perfect cubes. You're not as familiar with perfect cubes. Most of you are familiar with perfect squares, probably. So the perfect cubes are like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, right? Just to have cubes in your brain. 4 cubed is 64, 5 cubed, 5 times 5 times 5 is 125. I don't know, 6 cubed. 7 cubed, 8 cubed, 10 cubed. We should know 10 cubed is 1,000. 10 times 10 times 10 would have 3 zeros. So these are the ones I want you to recognize, like mental math. But I don't know 6 or 7 cubed myself. So here we go. These are all kind of within the ones I just listed. So what you do is to go from, this is a difference of cubes, we're going to use this difference of cubes formula. So what does it say to do? It says basically to get rid of the cubes and just write a minus b as part of your factors. So to get rid of the cubes here, I would have x, and I would just have -2, right? X minus 2 is the cube root of each of those terms. And then once you know the cube root, what does the formula say to do over here? Whatever a is, for us that's x, it says just make that a squared. So we're just going to make this term x squared. And then the formula says put a plus sign. So I put a plus sign. And then it says take your first term times your second term. So my first term times my second term is 2x. I'm kind of ignoring the sign because I'm supposed to put a plus sign there. So 2 times x is 2x. And then it says put another plus sign and then write b squared. So I'm going to put another plus sign and just write +4. And that's as far as that's going to go. This one is usually going to be, I think always, not factorable, right? There's no factors of 4 that would add up to 2. So that's considered factored form. And factored form helps you find your x-intercepts. So I know that this has an x-intercept at 2. We haven't reviewed that yet with polynomials, but factored form gives you your x-intercepts. This has an x-intercept at 2. Let's do B together, and then you can try C. So first step is to take the cube root of each of those terms. So the cube root of 1,000 would just be 10x plus 1, right? Because the cube root of 1 is 1. So now I've got to get my trinomial over here. The only difference is the signs. This is a plus sign. This is a minus sign this time. So my first term is going to be a squared. So 10x times 10x, 100x squared would be my first term. And then the formula over here, the plus formula, tells me to put a minus sign in my trinomial, so I put a minus sign. And then I have to multiply the first term times that last term. So 10x times 1 is 10x. So minus 10x. The plus tells me now to put a plus right there. And then b squared, 1 squared is 1. I kind of ran out of room, but plus 1. And I can tell that negative 1/10 would be an x-intercept, right? If I set that part equal to 0. And this is not factorable any further. There's no factors of 100 that would add up to negative 10. So see if you can do part C. Just take a shot at it. Doesn't matter if you get it wrong. Who cares? At least you'll be able to figure out what you do right and what you do wrong to figure out these cubic formulas. And I know this is hard, probably more challenging than you've been doing with factoring in the past. See if you got the same thing or something different, or where you went wrong. Right, so you take the cube root, that's where the 4x minus 5 came from, and then this becomes 16x squared, 20x, and then 25. So like I said, I would give you these formulas. I just want you to be able to say, oh, that's perfect cubes. That might be factorable. Okay, if I have the formulas, I could factor it into its binomial and trinomial correctly. And then the last form that you've probably never seen before, but it goes along with factoring polynomial functions, it's called quadratic form. And so it's whenever there's a fourth power, a squared, and a constant. You can actually think of this in your mind as the quadratic x squared plus 4x plus 3, because it's jumping in powers 4, 2, and constant. So it's interesting that it works out this way. You could just think of it as, if I was going to factor this, if this was just a quadratic function, I would factor it using the diamond method, right? What are the factors of 3 that add up to positive 4? That'd be 3 and 1, right? So x plus 3, x plus 1 are the factors of that quadratic. The only jump to make this the factors of this quartic function, this fourth degree, is to square both of those x's. So if you put this as x squared plus 3 and x squared plus 1, when you FOIL it out, x squared times x squared gives you x to the fourth. Your outer gives you your 4x squared, and 3 times 1 is 3. So I kind of use this as an in-between step to get my final factor. Now B is a little bit harder because B is going to require the box method to factor the quadratic. So 5x squared minus 9x plus 4. Let's do the box method together. This one I could do mental math for. This one's a little bit harder. So to set up the box to factor this, right, you put your 5x squared in the top, your positive 4 down in the bottom, and remember you still have to do your diamond. Is this how you guys had learned factoring? I hope I didn't teach you a brand new way you'd never seen. Okay, so you do 4 times 5 because this has a coefficient. So 4 times 5 is 20. I'm looking for the factors of 20 that add up to negative 9. Whatever I get here is going inside this box. So can someone think of the factors that I want to use? They both are going to have to be negative numbers to get multiply to get 20. Yes. So negative 5, negative 4 are going to become negative 5x and negative 4x inside our box. It doesn't matter where you put them. You could have put negative 4x up here, switched them. So now you can do the greatest common factor to factor that box. So see if you can finish when you get to the box of that next step of that factoring. So I took out 5x, x, negative 1, negative 4. So there's where I'm pulling my factors from, x minus 1 and 5x minus 4. To make it into this quartic function, I'm going to square the x terms, not the coefficients, but just the x's themselves. Do either of these go any further now that they're quadratics? So this, right, this step became this. This is my final answer. I'm just wondering, is this completely factored or could it go another step? You see one of them that could go one step further? One of them can go a step further, the other one can't because of difference of squares. So which one of these is difference of squares? I want your brain to be going like, buzz, difference of squares right there. Difference of squares, x squared minus 1 could be factored into x plus 1, x minus 1, but 5x squared minus 4 can't because 5 is not a perfect square. So difference of squares, I hope that your brain, whenever they see these specific types of problems, x squared minus 4, x squared minus 9, x squared minus 25, you could have 81x squared minus 49. As long as these are perfect squares and these are perfect squares, it goes to like x plus 2, x minus 2, x plus 3, x minus 3, right? Difference of squares needs to be like solid in your brain. All right, so that is the end of the notes, right? Because then the guided practice is on the back for when